Okay.
Good afternoon, everyone, and welcome to today's webinar entitled Maintaining Personal Hygiene in Clean Rooms in order to reach contamination-free medical products, organized by Pharmaconex exhibition in Egypt in association with Detail Engineering and DRRI, the German Institute of Clean Room Technology. My name is Rami El-Feki. I am the conference producer at Informa Markets Egypt, and on behalf of Pharmaconex's team, I'm honored of today's webinar. For Pharmaconex series of webinars and following up our last webinar that discussed the strategies to manage COVID-19 impact on the pharmaceutical landscape in the MENA region, today we're presenting you with a global practice that would help you reach contamination-free products. As you are aware, the current impact of COVID-19 has presented challenges that prevent us from coming together as an industry in person until restrictions are eased. And until then, we will be striving to present to you some of the trending topics and practices in the industry. Pharmaconex, the North African premier pharma trade exhibition, which connects the entire pharmaceutical value chain, capitalizing on Egypt being the biggest pharmaceutical producer in the MENA region, and in association with CPHI, will take place in accordance with Informa's all-secure health and safety standard, providing the highest levels of hygiene and safety at all of its events. Today, we're fortunate to be joined by Professor Dr. Gernot Dietel, who is the president of Detail Engineering and the president of the German Institute of Clean Room Technology, and AIT, the Adriatic Institute of Technology. Professor Dr. Dietel will share with us some extensive knowledge and provide insights about how to maintain personal hygiene in clean rooms in order to reach contamination-free products. We have only 1 hour for today's session, so Professor Dr. Dietel will do his presentation, and then we will allow some time for questions from the audience. I'd like to remind you that this webinar is designed to be interactive, and like I said, towards the end, we will be glad to answer your questions. So we encourage you to type your questions into the text box located to the right of the presentation window, or click the Q&A icon at the bottom of your screen and type in your question. Dr. Dietel, over to you.
Okay, Remy, thank you very much. I'd like to say thank you very much for your entry words, and I'd like to say as well, thanks so much to Informa and the team of Pharmaconex for organizing this webinar. Okay, everybody will. What is that? Yeah. So I think we will fight a lot during this session against the IT and the computer, and I hope more or less that everybody hears me loud and clear. And later on, if there are any questions, so let us know them. Thank you is right with me, and so we try to answer everything. So thank you. Okay, welcome here to the Bavarian Highlands, the center of clean air, and very recreation area, holiday area, and the home of digital engineering. So normally we shouldn't talk about microbiological or particle contamination, because here we see in this picture nothing is available. So a few words about digital engineering. 27 years ago, digital engineering was founded by my own person. You see the small history. We are nominated for right now for the next excellent award of the Cleanroom Engineering Specialist of the year 2020. We get awarded as a Cleanroom Engineering Specialist in 2019 and 2018. And as well, we have an award from the Building Better Healthcare, an organization in Great Britain, about this small thematic of Shelby hygiene and cleanroom systems. So first, sources of particular contamination. You will know and you will believe that the whole thematic of today is just only a short inside spectrum to all this thematics around hygiene, around microbiological contaminations and particular contamination. The source of particular contamination here is very easy. First, we have the materials in the production area. We have the process media as water, solvents, gases coming from external for the ambient atmosphere, for the personal stuff and safety. That's the manufacturer storage, and for the equipment, the packaging and transport systems. The highest risk point here on this slide is the thematic of the stuff, because it is not so easy to handle the stuff and to bring them all the ideas you have by yourself or you want to train them. Therefore, they need to understand how a clean room or our clean room technology is working. Here by the air circulation, you see in a short rip-off that you have a clean room, you have the entry area from the change room, from the fluids to airlock, up to the process area. And the whole area will be managed by conditioned air, transported air. We have therefore the particle separation as a final air filtration. Depends on the classification of the processes and the room by itself. We have the conditioning of the air. We have the pre-treatment of the air, the inside of fresh air. Therefore, you know, we need around about 20% or 20% of a total process area of the fresh air. And if you have around about 100 cubic meters an hour, so from this 100 cubic meters an hour, you have around about 20 cubic meters on real fresh air. And you have an exhaust of the contaminated air. So next. So no, the pressure cascade. So therefore, you have you see here the clean rooms, the clean room systems with the fluids, with the different classifications here managed by ISO class 6 or by GMP. The GMP is a good manufacturing practice responsible for the total system of aseptic technologies, and more with the with an intersection and intercommunication between the non-aseptic and the aseptic technologies. So therefore, what we need is each sector, each different glass, we need round about 10 to 15 pascal as a different pressure, and this 10 or 15 pascal we have from one area to the next. But if you consider about this classification and the hygiene factor, so please consider as well on which type of persons, how many persons, how many service engineers, how many visitors, and all the factors totally complete the total consumption air and all the necessary doings for the ISO and GMP classification. So most of the time, we never have a look about thermo and thermodynamics and fluid dynamics or air fluid dynamics. This airlift here will show you a very simple picture that you have a heat up sector, and by the heat up sector, the complete air which comes by pass by in the final filtration system, nearly touch the process area, and then heats up and turns back, and you have a big circulation in the room, a high turbulent systematic, which is not usable or should be not exist. Better you see this here in a picture. You see here the Sahara, you see here the end of Spain, and the outdoor, you know, this the deep pressure weather from the Azores brings you this high turbulence from the Atlantic Ocean, and therefore a lot of rain. And right now we don't like the rain. We have so much, and we need much more to sun. So for this case, the heat up of the air about a special type, and here you see the process type of our planet brings us the same as the thermo and airstream dynamic what you have in the clean room. So the particle classification you have to consider that they are given by the ISO or as well by local associations like BSI, like Chaka, like R3 Nordic, but last not least, we packed all of them to an international standardization classification. It's called EN ISO 14644. So here as well, you see the GMP classification A, B, C, D. And yeah, for your information, the next year, okay, maybe in 2 years, but everybody hopes next year, we will have a new, complete new brand of the GMP classification. The ISO classes will still exist. So, downstream of velocity of particles. It is very nice if you sit at home in your living room and you're looking to a spotlight, and on the spotlight you see, oh God, what's happened? A lot of particles running around or flying around, and they are still in the air. To give you a small impression about the thematic of downstream, here you see a particle of a size of 5 micrometers with has a theoretical velocity of 1.4 meters by 10 up to -3 seconds. So each second, 1.4 by 10 up to -3 each second. So that takes this particle needs 23 minutes and 49 seconds theoretical calculation to strip out on a distance of 2 meters, and that is not very much. So if you go down to the GMP number of 0.5 micrometers, so you have 1 day at 3 hours. And if you see now the part in a microelectronic facility or parts in the biochemistry and bio-nano thematic, you have a particle of 0.1 micrometers, and that needs around about 13 days to suck down to the floor. And then you're coming very high motivated, and like you're doing like a broom, and you're running, and behind that is a factor of square 2. All the particles are still in an air of around about 1.7, 1.8 meters, and everything you were waiting that's falling down is still in the air again. Okay, so to see the sizes and have a small impression about the sizes, where is the smoke here. So for a good cigar, it's nice. So you have the smoke particle. This is around about 1 micrometer. Then you have the dust with about 5 micrometers. You have the fingerprint, and the fat zone of the fingerprint is around about 30 micrometers. And a hair of this young little lady sitting here in front of me. Yeah, I have guests with me. That is very important. So the hair has a diameter of around about 60 micrometers. And to stop about such things, you have if parts like this to contaminate the air, I give you a small story. A couple of years ago, I want to know how clean is my environment, or my living room area. So I closed all the windows, have taken a film in front of the windows, a black one, that last not least, as everything was covered, the living room was completely dark. And with a particle counter, and you believe it or not, in around about 1 day, not one particle was detected by the particle counter. And then my wife said, "Oh, now let's open." She has taken only the film away, and then the particle counter started away to count and make beep, 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 beep. So what was happened? So the sun were shining in, and the sun creates a thermal effect, and all the small particles were located on the surface of the table or somewhere around. They started flying. And that is the same principle like in a clean room. So, and yeah, and here you see a real photo from a smell of a nail polish on a microchip. Why I show you this picture? It was nice. During an orientation, there was a young lady, and she had very, very, very extreme long fingernails. So, and I asked her and said, "Hey, lady, is it not very unprofessional to use a glove 3 sizes bigger than your hand? And in case of your fingernails, no, everything. She's well trained and I have no problem." And I turned around, and in this moment, a glass started rolling, and she catched it with her glove, and the fingernails were in front of the glove. So you see, that shows you that you need a high principle own controlling, not only for on your duty, on your job. No, you have to have the same principles at home, and that is an old word that the controlling of clean rooms, biological and particle controlling, needs as well a complete different thinking and a different behavior in your private life. So here you see this, what is going on every morning. Most of the people, you see a dried part of shampoo particles in the middle of short strip lines, and this is nice. So that is shampoo. You do this. You have a shower every morning or every evening, wherever, and everything you have in your hair you carry around with you, and last but not least, you bring it to your clean room activities. So the next thematic will be germs, pharmaceutical products. A couple of years, what was happening? A friend, I call this guy, a good friend, is the owner of a company, and they had a big problem with bacteria and contamination. Where this contamination came from? Okay, after a while, they found that this one guy from the process line has a farm at home, and every morning he had a shower, then he had breakfast with his family. It was nice. The children went to school, and and he went to the stall. He went across the farm and looked to his cows, and then, "Good morning, my baby here," and every 10 cows get the glove on the back, and then he started his way to the clean room, to the factory, and and a couple of days later, they had a big mistake. And what was happened? To find this, that was just his behavior from home, because he was clean, he had a shower and everything, but all the contamination was transported by his skin, by his hair, by his fingernails, by everything to the company. Or another thematic that you could imagine what does money mean. A couple of years ago, a big international pharmaceutical company started with a producement with an external company here in Germany, and after a while they detected some special germs, and the result was a lady had an influenza, and she was on duty just for the first week, and she was not going to her manager and say, "Sorry, I have 39.5 fever," and but because she had just 5 or 7 days on her job, and so she destroyed materials in a couple of weeks for a safety distance of 6 months for nearly $800 million. Okay, just for an influenza, what could be managed in a couple of days. So microorganisms. You see right now on COVID, microorganisms are very intelligent, And last but not least, if we die and the planet will be destroyed by everything, microorganisms still will survive. And the believe one part or one sentence for the microorganisms is a microorganism is a particle. If it's dense, it's a particle. And if you have particles, so microorganisms ride on the particles like cowboys. And so if you don't watch your hygiene, so you're never in a position to control the hygiene. So what you have, what is written in the European GMP Guideline Annex 1, that the manufacture of sterile medicine production from the classification A, B, C, D. So we have thematic addressed, and we have one system thematic in operation. And that's right now the numbers on the market. So as I'm informed, next year the system in operation will change the numbers. So I'm not in this committee, but we will inform very directly if the new numbers are coming. So we have different types of borderline values for the microbiological contamination, as well as the GMP classification A, B, C, D, and here for the coliforming units, each cubic meter of air. We have sedimentation plates, we have contact plates, and we have a fingerprint by the gloves. So please use these numbers and don't play with these numbers. It is not a game. So the game could be changed to a war. And if we have a war with such things, so it is always finally you stay in court, and some guy will make say a sentence against you, and this is not the real one. So let me see the next. Superpacs. So if you discuss about standard Staphylococcus aureus, so that's with everybody. So you have some on the ears, you have some on the nose, on left and right, on the eyes, and you have some on the poppers and in front of the genital area. So that is not a bad thing. You control your own one, and normally with a regular hygiene, so you have not a big or a problem. But if you start to have an influence with a methicillin-resistant Staphylococcus aureus, then normally by the time you will die on it. And that is not an easy dying, because I have thesis, and my father-in-law was infected by such a thing, and he died in a 6 months because the complete skin opened, and so more or less it is very, very dangerous. If you have a microbiological controlment inside of your factory, and you find some multi-resistant Staphylococcus aureus, so it's a problem. Not only for you, as well for your customer, for the market, and for the patient. The electronic is not doing what I want. That is, so here you see a few pictures I have taken for you of a multi-resistant Staphylococcus aureus, and all of them are created not on the open market or somewhere in the supermarket or wherever. No, created at home or by non-hygiene treatment in a hospital or by a doctor. So germs on surfaces and contact plates. So I know everybody knows it. What, 20 minutes? Oh, okay. I have to hurry up. Something. Thank you. Showed me I only have a rest of 20 minutes. Germs on surfaces. It is well known from everybody, of you, of us. But the thematic is if you are not trained by time, So it becomes wrong. What is going on with the training on hygiene here, on the complete training, not only for germs, for the use of contact plates. You need roundabout 3 months, or you have 3 months for standing knowledge. After 6 months, you lose roundabout 70% of the knowledge. And so you need a retraining. Think about that, consider about that, and don't forget. I know it is very, very simple, but very simple things killing our environment in the clean room. The microorganisms by themselves, you find everything. So here I show you the Ebola influenza. That is a standard influenza, and you see Lassa, and you see everything what we have everywhere. It is coli, and a colibacterium it's not the worst thematic, but if you could make a microbiological control when you are in an audit in a clean room and you have a swab and you detect the colibacterium, then you have to check up who is washing the hands after the toilet, and just only the hands after the toilet. This colibacterium is not coming from stainless steel surfaces or from top surfaces or whatever. It is coming from your daily business on the toilet. And so if you have the fingernails, it is below the fingernails. And if you say, yeah, but I brushed everything, if you are ordered, so my wife is doing this with me. She orders me to the garden, and my wife says, you plant this plant from here to here. So, and after 43 years of marriage, I do this because I want no more. So, but what is below your fingernail? You have spores, earth spores, and to kill these earth spores, you need roundabout 1 week, 1.5 weeks doing nothing, or you kill them with 185 degrees steam temperature by 15 minutes time of use. And show me your hands, 185 degrees steam temperature. So yeah, so you will understand that the coli or influenzas or earth spores, that's a different type of world. Coli is for us here the most important. Influenza, if you have a high temperature by 39 degrees body temperature, so you stay at home and you take care about yourself. Coli, nobody is feeling, oh, I'm contacted by a colibacterium. It comes, and if it's your own, then everything is fine. But if it's a front one and they don't like to get mixed, risk included, people and technique. I said before, you have to train the people to reduce your risk. How you're doing on your risk management for some field of microbiology. It is like parachuting, or you stay somewhere in an area and you don't know what is going on. And if you go on before you start in a clean room or before you start parachuting, you need to be trained, always trained. And that is training, one of the most, for us as well, one of the thematics needs professionalism. So if you see here Ferrari, if one engineer is doing a little mistake, which was maybe not trained, not his failure, they lose the race and they lose a lot of money. And that is the clean room the same. So typical mistakes in the clean room. Assigning protocols. Work wasn't done. Okay, sometimes you see the protocols like on a gas station on the interstate. Yes, I was there 12:15. The next cleaning 1 o'clock in the afternoon. The next and so on. That has nothing to do with professionalism. So the protocols, they are very important for first ISO 9000. and for your GMP and later on for your FDA compliance. So wiping sweat, the forehead. Yeah, it's nice. Yeah, thank you. He's doing this right now, and wow. And you take your hands and bring it to the trouser, and yeah, you see it. That is not a fairy tale. That's a real story, and that is going on every day. And most of the time, if nobody looks to them, so you have manufacture with turn gloves. Yeah, turn. Yeah, cut. No. The turn glove. You have the face stretching, so it's nice. Oh, or the hair. What was it? Yeah, that is the reason why after a couple of years, so the hairs disappear on this point. Not your hair, but sometimes it's, yeah. And my wife always says, "Oh, didn't you look for something, or didn't you know anything? So you scratched it." Oh, okay. Hair not completely covered. You have seen the hairs, the diameter of the hairs before, and overall contact floor while dressing. Yeah, that is the systematic. You have to train, you have to learn. So, impact on production hygiene. The personnel, together with the management, the production personnel, the staff, and the external personnel. If you have external personnel, so you have to control them. You have to look to them, how they are washing the hands in the black or the outside area, how they are washing the hands, and how they make their sterilization of the gloves, and do they use the garment perfectly, etc., etc., etc. And the same is for the management. It was nice. It was here not far away from us, a pharmaceutical company. And we had an auditation, and it was perfect. The auditation was great. And then the CEO came in, was dressed perfectly in a clean room dressing, had a few Japanese people with them. Everybody was perfect. And he directed to the processes, and yeah, then he left with the group, and then the door went open again, and he came in with his suit, not dressed by clean room dress. I forgot my mobile phone. So the audit was gone, finished. So, and that's another story. You see, the management needs the same training as more or less as a personal, or the management will be guided in the clean room. It is not like a jumping area, so can go in, can go out. And the same situation you have if the horn is ringing and you have an alarm, and yeah, you have to go in. You need to dress. If not, so the complete clean room is contaminated with unknown particles, and in this case with unknown microbiological material. And yeah, the stuff as well kills the training. So that is the same with interfering factors for the broad cleanliness level of the product. You have the management on one side, you have the production, what we had before, and you see the instructions, the garment, the maintenance and reprocessing, and so on. So let us see. Fluids. Very easy from the care area to the clean room. It needs not a very high complicated situation, but if you're following these three blocks here, you never will do something wrong. So go and use it as you have to use it. Yeah, in this case, everything is fine. So, geht's wieder? Sure. That is high tech. I call it, yeah. Geht nicht. So here you see entry system. You see outside it's a gray area. You have the black boxes. So it's a red situation across the corner that nobody is able to enter without using the sit over. So geht wieder nicht. So regulations and standards. Please follow this regulatory. And it is nice if you're discussing the US Federal Standard 209. It is canceled in the year of 2001 or something. And Julie Kendrick has sent a message around the world that the US Federal Standard now integrates into the ISO 14644. So laws and regulations are made to take risks away from you, to give you, last but not least, a better standing. And I know it is very hard time to follow the laws and regulations. So you have some for your national, you have some for the international, you have the SOPs. And if you start with a project, please start first before you start thinking which engineering and which area, everything. Start with a user requirement specification. And with the user requirement specification, last but not least, you find out which types of SOPs and which sectors you need them. So that is just a small help. So particles, emissions by staff is very interesting. You see, if you are sitting there, you emit round about 100,000 particles, bigger, even 0.3 micrometers each minute. And if you see then, if you're very stressy and you do more or less exercising in the clean room, you have to emit between 15 and 30 millions of particles each minute. But believe me, the belly is not disappearing. It comes back, all the particles. And you see why that gives you a reason or an imagination about your behavior in the clean room. So very easy, very still, very slow, so that you say, okay, I have no particles in the room. Another story is therefore during an auditation, the audit was nice, was good, fine, but on the another side of this area, there was a building with a CEO, and the CEO had a direct looking to the clean room area. And the people, what they're doing in the clean room, they were standing there, we had a discussion and everything was fine. And then the door opened, the boss came in and were shouting to everybody, move and go on with your job, why I pay you, and so on. Okay, thank you very much. Half year later, the company was not existing anymore. So you see that it's important, and if you consider on the right way, with everything, you never go wrong. Germs, the distribution, finger touch, hand touch, sneezing, saliva, and the no secret. You see how much it is, finger touch between 20 and 100 each square centimeters, hand touch a few thousand, but the no secret is 10 up 6 to 10 up 7 milliliters each milliliter. So hand disinfection. We say you pray 3 times, and that is from the time, very good. Or for children, you say, I tell my grandchildren, okay, if you start finger washing, sing a song, Hansel and Gretel, or 3 times, and that is working. So you need a time frame, and which step, last but not least, needs how many, what time. It's just learning by doing. First, but what is very important? First, wash your hands carefully, and the second one, disinfect. So you need a hand wash. That is the same. You brush your tooth in the morning, after lunch, and in the evening. And then to wash the fingers as well. So if not, so that's a small place, making a small test on the university with students after telling them before. And that was a test after lunch. It was beautiful. I have a lot of pictures more, but I show you only not so the worst schematics. So Okay, so gloves. Most of the people, they're using gloves like Robin Hood, and so in the front the skin is available and so on. So you see here how a glove is using. It is important that you have no fume come out covered with skin particles and hairs because everything is rubbing inside. And yeah, germ density, the different side. Here on the head, you have around about 1.5 million each cubic square centimeter. The forehead around about 200,000, and the axilla around about 2.5 million each square centimeter. That's a lot of stuff, but yeah, you will smell it very easy if you are in a train or in a bus, and you have a lot of people traveling with you, and you have this nice smell, and you know, oh, okay, there was no shower in the morning or whatever. And that is my best slide. That is developed or researched by the Institute of Health and Hygiene in Germany. And here you see the change intervals for underwear. 1, 4 days, 2 to 3 days, and smaller 1 day. You see the ladies? And oh God, yeah, and that is not a joke. That is reality. There are people, they're using their underwear longer than 4 days. That is unbelievable. But as I told you before, you smell it, definitely. And it is an absolutely no-go for people working in an under a microbiological controlled cleanroom system. Street clothes, intermediate garment, cleanroom garment. That is, if you stay in a cleanroom, the street clothes is not to use. You have it in a separate box, and the intermediate garment, that is to move from one fluid to the next, and the cleanroom garment is just only for the cleanroom. So the surface pollution of the street, everything is on your clothes, and so in this case, don't go directly from the outside or from the street. Use your street clothing as an underwear in a cleanroom. So you see why? Here you have the feather of the sweatshirt, of a t-shirt, of a polo shirt, and everything everywhere between. You have this little particles, and you have a lot of microbiological contamination. So protective clothing looks like this, and there is no U-turn, nothing. That is like if you go in, you have like you are going like a wrong way. So a particle flow to regulate is not possible. The fluids, that's unclean, and we had it before. The unclean side sit over, and the clean side. It is very simple, but the symbolism should be accepted and should be well known by the people, because I believe me, in 6 months and more, nobody is thinking about such things. They step over with their shoes and everything, but never thinking about that. So in this case now, I'm ready, nearly finished, and I hope that it was okay for a short entry. What am I?
Yes, thank you for this. We do have a couple of questions from the audience. So first question was, what is a class 7 clean room? If you can give more details about that. Okay,
a class 7 clean room is more or less GMP classification class D. So a class 7 clean room is written by the standard technology system by ISO 14644. So normally ISO 7 has nothing to do with GMP. So, and ISO 7 is just ISO 7 is just a classification number. Documents your how many particles are allowed from 0.3 micrometers to or now the last sector is last system is 0.1 micrometer up to the standard regulatory by 0.5, 5 micrometers and so on. But it is just for a non-aseptic use. The GMP is one side and ISO 7 is on the other side. How to properly
how to properly insulate clean rooms while ensuring they are fire resistant.
There is an own standard how to build up clean rooms and use a complete fire protection system. So that is from process to process different. What we have here, that was a small entry on knowledge. The fire protections are that's a part of here in Germany or as well in Austria or in Switzerland, that is regulated by government. And fire protection, there are different types of material on the market which give you this safetiness of fire protection. And that's as well usable if you design and if you engineer your clean room. Fire protection used for Airbus defense and space is completely different as a fire protection which is used for Bayer or for Novartis on their clean room areas.
Okay, the last question we have is, what is the reference for the maximum acceptable limit of germs in pharmaceutical and food products?
What is the reference for the maximum acceptable limit of germs in pharmaceutical and food products? That is a nice question. The food industry is right now is completely new on the way, and there are a lot of different standards available. There is not one guideline like on the 14644. What was this, Andre?
Okay.
What is the reference of the maximum acceptable of germs in pharmaceutical? Yeah, I showed you the picture. Wait a moment. Thank you. How to go back with the slide? Completely. Here. So here we have the particles. For we have the classification of A, B, C. C is now in this case round about the classification of ISO 7. And what's the next one? This is it's
yes.
It is yeah. Here no. Yeah, here now you see the slide shows you the journal of microbiological values for the discussions of the microbiological contamination. You have some in the air, and the microbiological, finally the microbiological, everything what you call on contamination is written and discussed in your user requirement specification, and could be as well based on your own experience. There is an experience available for different types of processes. It is you don't need to follow all this international thematic. You have to follow your product and your process, and then you make a decision about the which type of classification you like to use.
Okay, we actually do have a couple more minutes, so we still have a couple of questions. The question says, looking at BSL level 3 and 4 pathogens and the lack of facilities on the African continent, how immediate clean room technique can be taken for isolation and research and development for vaccine development?
Okay, now you're discussing here a biological and hazard laboratory class 3 and a hazard laboratory class 4. That is completely specified. That is an own technology. A class 3 or class 4 hazard laboratory means that it's completely closed. It is needs minimum 2 or 3 different sub-technologies, technologies working like a substitute. And so one air handling is not, in this case, it is not usable with the standard air handling. Class 3 and class 4, that's hazard laboratories used for pathogens or used for the research of Ebola, of Lassa, of COVID now, of influenzas, of all the big influence characters.
All right. Thank you very much, Dr. Dital. Unfortunately, that's all the time we have today. I'd like to thank our guest speaker, Dr. Dital, for joining us today, and all the attendees for also being with us. In order to better serve you in our future webinars, we'd like to have your feedback. So within the next hour, you will receive a personalized follow-up email with the link survey to fill, as well as today's recorded session if you wish to invite your colleagues to see it. So on behalf of our guest and myself, thank you very much, and see you in our next webinar.
I have to say thank you very much for this invitation. And if there is interest to following this line and go more in specified details, so I'm always available, and thank you. You will be with me, and we are stay always on your side. Thanks.
Thank you very much, Doctor. Have a good
Ciao.
day. Bye.